Okay, in this short video, we're going to talk about how do we add and subtract radicals. Now, you can kind of think about radicals the same way you would think about variables. And if you think about them in that way, it's easy to remember what you can and can't do with radicals. When we're talking about adding and subtracting radicals, they can only be added and subtracted combined if they have the same radicand. Just like you can only combine like terms if they have the same variable raised to the same power, you can only combine like terms here if the radicals are the same in terms of the radicand. Okay, and so when they're the same, all you're doing is combining them like terms. Here I've got 7 of the square root of 17. And I'm going to add it to 19 of the square root of 17. And so what we get is 7 plus 19 times the square root of 17. And we know that to be 26 times the square root of 17. For this next example, we're going to take the square root of 17x minus 20 times the square root of 17x. Well, what is the coefficient of this first square root of 17x? This is the same as 1. So this is going to be the same, since we have the same radicand, as 1 minus 20 times the square root of 17x, or negative 19 times the square root of 17x. Okay, looking at example C here, I have a radical 3 and a radical 12. That's a problem. I can't combine them because they don't have the same radicand. Oh, but wait, can this square root of 12 be simplified? Let's see. Let's think about what we did in the last video. We thought about the radical as the product of two radicals, one with a perfect square factor, the largest perfect square factor, and one with any left over. So what is a perfect square factor of 12? Hopefully you said 4. And 4 times 3 would give us that radical of 12. All right, so the square root of 4 times the square root of 3 is the same as the square root of 12. What is the square root of 4? We know that is 2 square root of 3. So what I'm really doing is adding 7 square root of 3 to 2 square root of 3. So this would be 7 plus 2 times the square root of 3, or 9 square root of 3. Excellent, excellent. All right, so let's take a look at this last example. It looks here like we have two different radicands. So let's think about what will happen when we simplify them. Okay, so let's think about the square root of 20. What is the largest possible factor of 20 that's a perfect square? Hopefully you said that's going to be 4. 4 times 5, it gives us 20. And so the square root of 20 is equivalent to 2 square root of 5. Okay, then let's look at the square root of 125. Perfect squares. Perfect square factor of 125. Hopefully you are able to come up with, this is going to be 25 times 5. And so this is going to end up being equal to 5 square root of 5. And so now we're going to combine these like terms. 2 square root of 5 minus 5 square root of 5. That's going to be 2 minus 5 times the square root of 5, also known as negative 3 square root of 5. All right, hope that helps you, and I'll see you next time.